luck, everyone. I'm Olivier. I'm a master's student at Université de Montréal, and this project has also been done with Marc Philippe, who is my supervisor and full professor at Université de Montréal. So Marc will be in the chat. If you have any quick question, you can maybe try to ask them in the feed and see if Marc asks them, answer them. Otherwise, you can ask on the Q&A. So our story starts at during the fall 2020 semester, actually a bit before the fall 2020 semester, where when we started seeing that the semester was going to be given through distance learning due to the pandemic. And we were going to give that class, which is Programmation 1, and it's a mandatory programming course in our department. And it has large class of students with little to no experience at all in programming. Most of them don't know at all about how to program, don't know about what a shell is, don't know about Linux, and so on. And also, we were going to give that class for the first time in Python for that semester. So knowing that the semester was going to be remote, we started thinking, and we thought that we needed an environment which would allow this remote teaching of programming to novices. And we had those ideas. We first wanted it to need no installation at all, because we did not have access to any lab to install software, and we had something like 250 students, I think, for that class. We also wanted to have a very simple UI. So in the bottom here, what you see is the PyCharm UI for Python, and it has a lot of buttons for coverage, for profiling, and for novices, we want to avoid overwhelming them through these complex UIs. This is an example of what we did not want to have for novices. And we also had this idea of fine-grained single stepping, and by that we mean we wanted an environment which can do single stepping, but not line by line, but really sub-expression by sub-expression to be able to show data flow in the program. And we finally had this idea of having shareable state through hyperlinks to be able to show one specific point of execution and embed them in slides through links. And you will have examples of that through the slides. So we started looking around, and of course we had a look at PyCharm and Jupyter, which are well-known Python development environment, but those are really for professional developers, and this is not quite what we were looking for. So we continued looking, and we found some environments which are specific to teaching. One of them is TFPIE, and the other one is Online Python Tutor. And actually, Online Python Tutor is the closest to what we were looking for. The way it works basically is it takes source code from the browser, it sends it to a server where it executes it with the Python debugger module. And then it sends back a trace of the whole execution, and the client will actually go through that trace, which acts as a timeline. It can actually go forward and backward. So a lot of interesting feature in there. But the problem is it didn't have that fine-grained single stepping. And also the fact that it is server-side executed prevented us from teaching that event-driven programming part of the class, which was in the last module of the class. So at that point, we knew we kind of had to implement our own environment to get what we were looking for. And we started looking at which Python interpreter we should use in the browser. And we had a look at a few. There is Brighton, Pyodide, and Scope, which are what we found to be the three most mature Python interpreter for the browser, but none of them support that fine-grained single stepping and snapshot of that specific point of execution, which you can share through the micro. So this talk will be about what is codeBoot exactly, how we implemented that fine-grained single stepping, and finally we'll give you some example of what application you can build with codeBoot. So first question is, what is codeBoot? Well, this here is codeBoot. If you were to go at codeboot.org/py, which you can do right now. It's available. You would see first a runnable preview console here for Python, and just 4 buttons here which allow to execute the code in different modes. I'll actually click that link here, and here we have codeBoot. So I have my console here. Let's say hello. So hello everyone. Uh, and you can execute code as you would normally, but you also have that special mode. Suppose I have an expression. So I hope you can see here it's 1 plus 2 times 42. And you have this button here on the top right, which says single step. And if I click on that, you have evaluation of your expression, but sub-expression by sub-expression. So here you have the evaluation of the 1, the 2, the 42, and you can see that the 2 and the 42 are being combined to 84. And finally, you have your plus 1, which gives 85, and if I hit one more time, you have the result being printed to the console. So, especially in our context where we have students who have limited background in mathematics, by example, teaching data flow and order of operation here is something which is very helpful. So, codeBoot also offers other features. By example, here you have a local file at the bottom, so spiral.py. Files are entirely local to browser, nothing is server side, and they can also be imported through files and in your console as you would with Python module. One other thing you can see here is in the previous example I gave, you did not have any variable in the scope, but here you can see that at the evaluation of this expression right here, you actually have n and spiral, which is a global variable. And you can see the environment in that yellow bubble, which we call the environment bubble. You also have a step counter here, and this allows to give a kind of a basic sense of cost of execution to students. And here you have what we call our playground. And the playground allows you to do different kind of drawings. And here you have an example with turtle. I'll actually open the example. And you see that by clicking on the link, I was actually able to open codeBoot at this specific point of execution. And what I'll do here is I will resume execution with the second button, which will execute with animation. So it will actually execute slowly. And you see the different point of execution. So this allows you to see the control flow of the program. And I'll actually make it a bit faster. So let's go in turbo mode. And you can see the turtle on the top right drawing scribble. Okay, so now that you have an idea of what codeBoot is, we discussed I see a lot of art in the chat. So we discussed the Python interpreter that codeBoot uses. So the main challenge we have is that single stepping will need the UI to update during the code execution. By example, for showing the yellow bubble. But the browser will require JavaScript to execute until completion before ending any event. So we have this problem of how do we go from executing the Python code to drawing the yellow bubble, the environment bubble. And the solution we found was actually to write the interpreter in continuation passing style. So continuation passing style, CPS, is what will allow you to run your program and at some point save the state as a continuation to be executed later. And each continuation will actually allow you to run one more step. And since we are in JavaScript and that JavaScript in the browser doesn't guarantee tail call optimization, well, we need a trampoline for this CPS. But in our case, the trampoline actually has a dual purpose. It's also what we manage the interface between the browser and the interpreter itself. And the way it works is like this here. You have the trampoline in the middle, right here. On the right, you have the interpreter, and on the left, you have your UI. Your browser. And so the trampoline will start the execution of the code and let the interpreter run for a while. And at some point, the interpreter will pause and return a continuation. And here the trampoline can do two things. It can just call the continuation if you are in execute to the end mode, or you could um, store the continuation because you realize you are at the end of an expression and you're in single stepping mode. And then it gives the control to the UI so that the browser can draw the bubble light. And once the user clicks the play button here, then the control will be given back to the trampoline, and the trampoline will restore get the continuation, call it back, and then the interpreter will execute one more step. The question that remains here is, what do we compile the code to start this execution? And the technique we use is actually based on fast interpretation. So this is a technique which will take the abstract syntax tree and will compile it to a function. So here we have a JavaScript function that when we call it, it executes the code. And I'll actually give you an example of that on the next slide, but I just want to warn you first. We've been discussing of an interpreter in the browser, so you probably expect JavaScript, but the interpreter is actually written in Python. And long story short, we already had a few components for this interpreter before we started the project, and they were written in Python. So what we decided to do is to continue doing in Python in a very basic style, such that we could write in a compiler, which we call P2J, which will compile from Python to JavaScript. So that gave us, from this Python version, a JavaScript version of the interpreter. And this is what is being served and used by codeBoot to compile user code. So now let's have a look at the code from the interpreter. We have a snippet of code here. This is the code which is responsible for implementing and compiling the object.attribute construct in Python. So you have this gen attribute function which will generate that function which evaluates the attribute. It takes four arguments. First, your compile time environment. It takes the abstract syntax tree, the node for this attribute. And it also takes the object code. And object code here is a function which will evaluate the object on the left, this object here. So gen attribute is really responsible only for accessing the attribute, for compiling the code for accessing the attribute, not for evaluating the whole object of attribute. So it just go get the attribute. And finally, you have the name of the attribute you want to access. This gen attribute function will create a closure here, which is the code function, which is then returned along with the compile time environment. And this is what will be used by the trampoline to execute the code. And this code function will take two arguments, the runtime environment, first argument here, and a continuation, which is what should we execute after we are done with evaluating the attribute. And what this function code will do is, of course, at first it will call the object code function to evaluate the object on the left. And to this object code function, it will give a continuation which will call the call get attribute function. And I don't want to get too deep into this call get attribute function, but what it does is call the semantics for getting attribute. And this is actually, for those who know Python, this is what we call the dunder method get attribute, and then the dunder method get ATTR that fails. So the whole Python semantics for attribute getting is implemented in CPS in that function send get attribute. And finally, one thing which you notice is this expression and continuation. And this here is a continuation which is passed to call get attribute. And this is a special continuation which when called will return to the trampoline with a special flag which says we are at the end of an expression in the sense of the Python semantics. So through the compiler, you have those expression and continuation which will flag the trampoline and say, okay, if you are in step-by-step mode, right now, you should pause and draw your environment bubble. So now let's have a look at a few web applications we can build with codeBoot. I'll start by this one here. The idea is that codeBoot can actually implement standalone web applications. And I'll just click that example here. And here we just open codeBoot. And you have a tic-tac-toe game, which allows to play tic-tac-toe here. So you see I have some event handling and I have changed the DOM and I can even continue. And here when I win, I have this alert which says X is the winner. And this is actually running entirely in codeBoot because codeBoot has three modes. It has the full window mode, which you've seen before with the code, which is a fairly large app to build here, a medium-sized app. It also has this high codeBoot mode, when you just want the app to be shown, but you don't want the code to be seen. And finally, you also have that cool floating window mode, which you can resize, so you can do some debugging on the side with your app running. So as you can see, we really wanted user interaction to go beyond just text input and output, because we're in the browser and we want to teach modern programming to students. So we implemented the browser alert, prompt, and confirm. You've seen the alert in the last example. We also implemented a get mouse built-in function, which will give the location and state of the mouse to Python. We also implement event handlers, which can execute Python code, for example, on click and on key press event handler. And we have multiple ways to have graphical interface. You've seen the turtle module at the beginning of the talk, but we also have a way to have a grid of pixel, and I'll give you another example here. Here you have a way to have a grid of pixel where you can actually detect clicks with get mouse, and here we implemented a minesweeper, which goes like this, and all of those are small pixels, so there is no images being used. It's really written, it's drawn pixel by pixel, and you can play your game, and you can even lose the game here with an order, which says that yes. And this one is a fairly large program, which is written entirely in Python. We also allow manipulating the DOM. We've seen that in the previous example, but I want to give a smaller example. The idea here is that you have a document object, which is a Python object, which acts as a proxy to the JavaScript document object. And here we can change the inner HTML of, here we change the inner HTML of the codeBoot HTML window, which is the ID for the playground. And we added a button with an on-click event, which is, the event handler is this click function in Python. And this will just increment a counter, but as you can see, if I click the button, I have Python code being executed, and I see the counter incrementing in the console. So I'll conclude here. codeBoot was designed to teach novices, and we implemented that fully in browser Python environment. It allows that fine-grained single stepping at sub-expression level we were looking for. And you've seen through the slide that when I click those images, we can actually open to a specific point of execution in the Python code. We also allow interfacing to the DOM, and this is what allowed us to teach event handling programming in Python. In the future, we would want to use codeBoot for more advanced programming courses, and for that, we'll need to implement a broader subset of the language, or actually, eventually, the whole language. Because for that class, which we had, we only implemented basic construct in Python. We stopped at defining classes and exception handling and so on. So if you enjoyed the talk and if you want to try codeBoot, it is available as for right now. You can go at codeboot.org/TY and give it a try. You're really welcome to try it and give us our feedback, your feedback. And thank you for being here. And I suppose I will now be taking questions.
Yeah, we have some questions posted in the question answer thread, and I will read them for you. The first one was by Peter Koopman. What is a large class in number of students?
What was the large number of students? Yes. We had 250 students, something like that. A few left during the class, but we were in the few hundreds. And that's one of the reasons we really wanted to have no installation required, because they are each working on their own machines with different versions of their OS, and it was out of the question for something they had to install.
The next question was from Yusuf Watara. You somehow has answered it yet, but I still will read it. We wanted the same for our first year Python course. Ended up choosing Sunny IDE. It works on the desktop, small download. Most browser-based IDEs so critical. It's so why.
Well, I don't know about Tony ID, so I cannot really compare, but we also wanted to give this kind of idea of what modern programming is, and event handling was one part of it. So we felt that in the browser, it worked pretty well. And there's also the fact, this is something I've not shown, but I have an example here. We wanted this idea to be working with quizzes we were giving during classes. So here you have an example of a quizzes being given during the semester where you can enter your code in a file in codeBoot right here, and you can actually directly submit it. And this required students to connect to the university platform so that they can submit their code directly there. And that's one of the reasons which made us develop a codeBoot in the browser. And I'm sure there would be other ways, but at the time, that's the solution we chose. And at that point, we think it was a pretty good solution.
Thank you. And we still have some time. The next question is from Lucas Bartocha. I'm apologizing if I'm pronouncing, if I'm misspelling the names. Is it somewhere available source code to contributing this application?
Well, as for right now, the code is not public, but I'm sure that it will become public eventually. If you wish to help, what I suggest you do is you contact us. Maybe we could see each other in the lounge after. But right now, as for right now, the code is not public.
The next one from Peter Afton. How large do the continuations become?
Sorry, can you repeat the question?
How large do the continuations become?
You mean the stack, I suppose? I say thumbs up, that's probably.
Yeah, the size of continuations.
I am not sure how, I cannot give a number of how deep the stack becomes in the continuation, but what I can tell you is that we have a Python version of the interpreter, and Python has a fairly small limit of how big the stack can get, and even the Python version never has any stack overflow problem exception. So I would say maybe it gets in the 100, no more than that, but I cannot give you a specific number. I see another thumbs up, I suppose it's probably.
Yeah. And the next one from Mark Marazan, how do you handle error messages?
Well, how do we handle error messages? We have a special way to return to the TFPIE saying that this expression ended with an error, and then the error message is just written into the console, and the execution stops. We do handle event handler, and in that case, the runtime environment has some continuation which can be passed to exception to be passed to the exception. That's the way we did it.
Thank you. And the next one is from Alex Duppo. Why Python? Why not JavaScript as you are in a browser anyway?
Yeah, well, it turns out that we have a JavaScript version of codeBoot. We really focus on the Python version because we feel it's more interesting to have Python in the browser. But the reason we use Python is we have a pretty large group for artificial intelligence at Université de Montréal. And so using Python is a change which was done in the department. And we know that if we teach them Python at first, they will be reusing that in their future courses. So that's one of the reasons for that choice.
I see. Thank you. And I presume this will be the last question because we are running out of time. The question by Daniel Warnes. How do tools like codeBoot, how well do they learn with it? Can you compare it to previous other environments?
Well, at first it's hard for us to compare to previous environment because this semester was really peculiar due to the pandemic. But we did have some feedback from students, and in general, students really enjoy the simplicity of codeBoot, the fact that no installation is required, that they have 4 buttons, and at that point, that's basically what they need: start code button, stop code button. Uh, we had some comments from students who were not new to programming, who had more knowledge. And for those, they did not like the fact that they had some restriction on which part of the semantics in the language they could access. So overall, novices really enjoyed codeBoot, but students who had more experience did not like it as much. So this kind of comforted us in the fact that we really implemented something which is aimed at novices program.
I see. Thank you for this session, for question and answers. It was an interesting session with a lot of questions, and I presume the others can ask their question in lunch on the table with the presenter. Thank you very much.
Thank you, Dmitry. Thank you, everyone.
Goodbye.